Welcome to mathematics class, matrices part 8. So today we are going to discuss adjoint matrix, and a singular, non-singular matrix. Which is very important concept in this chapter. First, let us look at this singular matrix, asadharana matrika, and non-singular matrix, sadharana matrika. A square matrix is said to be singular matrix if its determinant is 0. Otherwise, it is said to be non-singular matrix. Determinant 0 అయితే అది singular matrix, అసాధారణ మాత్రిక. Determinant 0 కాకపోతే non-singular matrix. If determinant is 0, it is singular matrix, and determinant not equal to 0, it is non-singular matrix, sadharana matrika. Determinant 0 అయితే అసాధారణ మాత్రిక, singular matrix. If determinant not equal to 0, it is non-singular, that is sadharana matrika. Now, very important concept, adjoint of a matrix. మాత్రిక యొక్క అనుబంధ మాత్రికను ఎట్లా కనుక్కోవాలి? What is adjoint matrix and how to find? The transpose of the matrix formed by replacing the elements of a square matrix A with the corresponding cofactors is called the adjoint of A and is denoted by ADJ of A, adjoint A, read as adjoint of A. A యొక్క అనుబంధ మాత్రిక అంటాం. ఏ అనేది ఏదైనా ఒక చతురస్ర మాత్రిక అయితే ఆ మాత్రికలోని మూలకాలను వాటి కోఫాక్టర్స్ చేత, సహగుణావయవాల చేత మార్చినట్టయితే ఆ మాత్రిక యొక్క ట్రాన్స్పోజ్, వ్యత్యయాన్ని అనుబంధ మాత్రిక అంటాం. యు కమ్ టు నో వెన్ వి ప్రాక్టీస్ ప్రాబ్లమ్స్. అంటే if a square matrix is given, first find out cofactors, then transpose the cofactor matrix, you will get a adjoint matrix. So how to find adjoint matrix? First find the cofactor matrix, then the transpose of the cofactor matrix is the adjoint matrix. The another very important concept in this chapter, invertible matrix, మాత్రిక విలోమనీయత. ఒక మ్యాట్రిక్స్ ఇన్వర్టబుల్, విలోమనీయ మాత్రిక. Let A be a square matrix. We say that A is invertible if a matrix B exists such that AB is equal to BA is equal to I unit matrix, where I is a unit matrix of the same order as A and B. For a square matrix A, another square matrix B exists such that AB, the product of AB is equal to product of BA, and that is equal to unit matrix. If such matrix B exists, then we call A as invertible matrix. A అనే ఏదైనా చతురస్ర మాత్రికకు ఒక B అనే మాత్రిక వ్యవస్థితం అయితే AB ఈజ్ ఈక్వల్ టు BA ఈజ్ ఈక్వల్ టు I అయ్యే విధంగా B అనే ఒక చతురస్ర మాత్రిక వ్యవస్థితం అయితే అప్పుడు ఏను విలోమనీయ మాత్రిక అంటాం. A ఈజ్ ఇన్వర్టబుల్. You notice the following. For the product AB and BA to be both defined and equal, it is necessary that A and B are both square matrices of the same order. ABలు ఒకే తరగతికి చెందిన మాత్రికలై ఉండాలి. AB BA నిర్వచించబడాలంటే both should be of the same order. Both should be square matrices of same order. Thus, we can notice non-square matrices are not invertible. చతురస్రము కానటువంటి మాత్రికలు విలోమనీయము కావు. You can remember, only square matrices are invertible. If A is invertible, then it is non-singular. If A is invertible, then it is non-singular. That is, determinant of A is not equal to 0, then only it is invertible. Only non-singular matrices are, only non-singular square matrices are invertible. సాధారణ చతురస్ర మాత్రికలు మాత్రమే విలోమనీయం అవుతాయి. If det is not equal to 0, if det is equal to 0, then it is not invertible. So if det is equal to 0, we call it as singular. So if det not equal to 0, it is non-singular. So only non-singular matrices are invertible. సాధారణ మాత్రికలు మాత్రమే విలోమనీయం అవుతాయి. అసాధారణ మాత్రిక విలోమనీయం కాదు. దాని పేరులోనే ఉంది అసాధారణం అంటే ఇట్ ఈస్ నాట్ ఇన్వర్టబుల్, విలోమనీయం కావు. If B exists such that AB is equal to BA is equal to I, then B is unique and is denoted by A inverse and is called multiplicative inverse or inverse of A. AB is equal to BA is equal to I అయితే the product AB is equal to BA is equal to I. I is where I is a unit matrix. Then B is unique and is denoted by A to the power -1, that is read as A inverse, that is multiplicative inverse or inverse of A. A యొక్క విలోమ మాత్రిక అంటాం B ని. So B is the multiplicative inverse of A, and that is A inverse is equal to B. B ni A యొక్క విలోమ మాత్రిక అంటాం. This is very, very important concept. AB is equal to BA is equal to I, then B is the inverse of A. So A inverse is equal to B, or B inverse is equal to A also. Let A and B are invertible matrices, then A inverse AT and AB are invertible. If A is invertible, then A inverse also invertible and A transpose is also invertible, and AB also, if A and B are invertible, its product is also invertible. And further, A inverse whole inverse, that is equal to A. If you take 2 times inverse, it becomes A. Then A transpose inverse is equal to A inverse transpose. And AB whole inverse is equal to B inverse A inverse. So these are some important concepts in this chapter, very, very important. Next, inverse matrix. Let us find inverse matrix. So that is adjoint and inverse. Very important in this chapter. Theorem. If A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3 is a square matrix, is a non-singular matrix, is a non-singular matrix. సాధారణ మ్యాట్రిక్స్ మాత్రిక అయితే ఏ అనేది సాధారణ మాత్రిక నాన్ సింగులర్ మ్యాట్రిక్స్, దెన్ A is invertible, then A is invertible, విలోమనీయం, and A inverse is equal to adjoint A by det A. Adjoint A by det A. This is very, very important theorem. So now let us prove it. Proof. Very important theorem. So let A1, B1, C1, A1, B1, C1. Let A1, B1, C1 let the cofactor matrix of A is equal to B, that is A1, B1, C1, A2, B2, C2, A3, B3, C3, where A1, B1, C1 are the cofactors of, where A1, B1, C1 are the cofactors of A1, B1, C1 elements respectively. Is capital A1, B1, C1 are the cofactors of the elements of A, small a1, b1, c1 and so on. That is, capital A1 is the cofactor of small a1, capital B1 is the cofactor of small b1, capital C1 cofactor of small c1 and so on. That is, capital A2 is the cofactor of small a2. So these capital letters are the cofactors of the elements of A. Now, the adjoint A is by definition adjoint A is equal to the transpose of cofactor matrix. That is, if you convert the rows into, by interchanging rows into columns, you get transpose. దీని అడ్డు వరుసలు నిలువు వరుసలుగా మారిస్తే దీని ట్రాన్స్పోజ్ వ్యత్యయ మాత్రిక వస్తుంది. దట్ ఈస్ బి ట్రాన్స్పోజ్ అంటే బి యొక్క వ్యత్యయ మాత్రిక. ద ట్రాన్స్పోజ్ ఆఫ్ బి, హౌ డు యూ గెట్? ఇంటర్చేంజింగ్ ద రోస్ into columns. So A1, B1, C1 is the row. I am changing it, I am writing it as column. So A1, B1, C1, the row becoming column. The second row A2, B2, C2 becomes the second column. A2, B2, C2, and third row becomes third column. A3, B3, C3. So this is adjoint of A. Now let us multiply A into this adjoint A. Let us multiply A with adjoint A. That is A1, B1, C1, A2, B2, C2, A3, B3, C3 into A1, B1, C1, A2, B2, C2, A3, B3, C3. This is adjoint. So we know how to multiply rows of first matrix should be multiplied with columns of second matrix. So rows into columns, R1, R2, R3, C1, C2, C3. So rows into columns. Now R1, C1, R1, C1 R1, C2, R1, C3, R2, C1, R2, C2, R2, C3, R3, C1, R3, C2, R3, C3. So this is how we multiply both matrices. Now look at this. R1, C1. I multiply the first row with first column. Small a1 into capital A1 plus small b1 into capital B1 plus small c1 into capital C1. So this is R1 C1. Similarly, R1 C2, A1 A2, A1 A2 plus B1 B2 plus C1 C2. Next, R1 with C3, third column. So A1 A3 plus B1 B3 C1 C3. Next, R2, multiplying R2 with C1, that is R2 A2 A2 A1 plus B2 B1 plus C2 C1 and R2 C2 A2 A2 B2 B2 C2 C2 R2 C3 A2 A3 B2 B3 C2 C3. Next, third, similarly, third R3 C1, that is A3 A1 B3 B1 C3 C1 A3 A2 B3 B2 C3 C2. Next, R3 C3, third row into third column. So A3 A3 B3 B3 C3 C3. So this is how we multiply both matrices. Simple multiplication. Now we know what is determinant. So A1 A1 B1 B1 C1 C1 is nothing but a determinant. So here this is nothing but a determinant and this is nothing but a determinant and this is nothing but determinant. Element, the sum of the product of the element with the cofactor of any row or any column is the determinant. ఇది మాత్రిక నిర్ధారకము నిర్వచనం. So this becomes det A. This is det A. So all other will become zeros. By definition, this becomes 0. and this A2 A2 B2 B2 C2 C2. So this is det A and this is det A. This is the definition of determinant. Next, taking det A common, this can be written as det A into 1 0 0 0 1 0 0 0 1. So taking det A common, you get this one. So this is nothing but det A into, this is the unit matrix I. So therefore, what we get, A into adjoint A is equal to det A into I. So this is, if you bring det A this side, you can write it as adjoint by det A is equal to I, since det A is not equal to 0, you can divide it. It is non-singular, the determinant is not equal to 0. So let us name it as 1. Similarly, we can prove, adjoint A by det A into A. Adjoint A by det A into A is also equal to 1. Almost similar. A into adjoint A by det A is the unit matrix I. Similarly, we can prove if you take adjoint into A, you will get the same thing. So by 1 and 2, combining 1 and 2, now from 1 and 2, we get A into adjoint A by det A, or adjoint A by det A into A is equal to I. So this is, if you take adjoint A by det A as B, so this can be written as, this is in the form of AB into BA is equal to I. If you take adjoint by det A as B. So this is the definition of inverse matrix. AB is equal to, if AB is equal to BA is equal to I, then this implies A inverse is equal to B. This is by definition of inverse matrix. So here what is B? Adjoint A by det A. So therefore A inverse is equal to adjoint A by det A. This is very important theorem. Adjoint inverse, A inverse is equal to adjoint A by det A. ఇది A యొక్క విలోమ మాత్రిక ఎట్లా వస్తుంది అంటే అడ్జాయింట్ A by det A. So this is the inverse of any square matrix. Very, very important theorem in this chapter. Look at this once again. The theorem, if A is A1, B1, C1, a 3 by 3 square matrix, then 3 by 3 non-singular matrix, then show that A is invertible and A inverse is equal to adjoint A by det A. So this is how we prove. First we find the cofactors, then adjoint, then multiplying A into adjoint A and proving A into adjoint A by det A is equal to I. Similarly, adjoint A by det A into A is equal to I. So by 1 and 2, we get AB is equal to BA is equal to I. By definition, A inverse is equal to B. That is A inverse is equal to adjoint A by det A. Very important theorem. Now let us practice some problems from the exercise. So now from exercise 3E, let us practice some problems. Roman first question. Find the adjoint and inverse of the following matrices. Find adjoint and inverse అనుబంధ విలోమ మాత్రికలు కనుక్కోవాలి of the following matrix. The first one, 2 minus 3 4 6. 2 minus 3 4 6. So this is one, and I will take third bit, 102 210 321. So let us find adjoint and inverse of both the matrices. Now first one, let A is the given matrix 2 minus 3 4 6. So let this matrix be A. మనం A అనుకుందాం ఇచ్చిన matrix. And first we have to find adjoint and then determinant. It is 2 by 2 matrix. Clearly it is a square matrix, non-singular. Now the definition A inverse is adjoint by det A. Now let us find first adjoint. So adjoint. So if A is equal to, if A is AB, C, D, if A is ABCD matrix, then adjoint is equal to, just interchanging this, interchanging the diagonal and changing the sign of other diagonal. So D minus B, D minus B minus C, A. So this is the adjoint. We are changing the first diagonal, interchanging the first diagonal, and sign changing the second diagonal. ఈ మొదటి కర్ణము పరస్పర మూలకాలు మారుతాయి. ఏ ప్లేస్లో డి వస్తుంది, డి ప్లేస్లో ఇన్ ప్లేస్ ఆఫ్ ఏ వి రైట్ డి, ఇన్ ప్లేస్ ఆఫ్ డి వి రైట్ ఏ. అండ్ ఫర్ బీసీ we change the sign, plus b becomes minus b, plus c becomes minus c. So this is how we find adjoint of 2 by 2 matrix. Very simple. Therefore here adjoint A is equal to, interchange this 2, 6 and 2, and change the sign, minus 3 becomes plus 3, this is minus 4. So this is adjoint A. So adjoint A, very simple. Now let us find inverse. So for that we need det A. Now let us find determinant. Det A is equal to, for any 2 by 2 matrix, that is AD minus BC. Det A is AD minus BC, where A is equal to ABCD. ABCD అనే ఒక మాత్రికకు దాని నిర్ధారకం det A ఏమైందంటే AD minus BC. Already we did with so many problems. AD minus BC, just like cross multiplication. So now let us find that det A. So this is the definition of det. Now here, what is AD? 6 into 2. AD 6 into 2 minus BC 3 into minus 4. So that is equal to 12 minus into minus plus 12. So that is 24. The determinant of this matrix is 24. Now inverse, we have to find inverse. Inverse is equal to adjoint A by det A. So this is the formula. Inverse is adjoint by det. So therefore here A inverse is equal to, what is adjoint? 6 3 minus 4 2. 6 3 minus 4 2. This is adjoint. So by det A, by you can write it as 1 by 24. This is the det A. Determinant is 24. So by 1 by 24 adjoint A by det A. దీన్ని ఈ బై అనేది సైడ్కు 1 by 24గా రాయొచ్చు. సో దిస్ ఈస్ ద డిటర్మినెంట్ ఆఫ్ 2 by 2 matrix. So finding the determinant of 2 by 2 matrix is somewhat very easy, and it is different from 3 by 3. For 3 by 3 there is a different procedure. Now let us find the second bit, that is another one. Let the given matrix as A 102 210 321. So this is the given matrix, 3 by 3 matrix. We have to find adjoint and det, then A inverse. To find adjoint, we need cofactors. Now let us find cofactors. So cofactors of first one, cofactors of 1, let cofactor of 1 be A1, capital A1. So how to find cofactor? Taking the 4 elements. So neglecting the row and column, taking the 4 remaining elements. 1 ఉన్నటువంటి రో కాలం ఎలిమినేట్ చేస్తే మిగతా 4 ఎలిమెంట్స్. సో హియర్, so this is after eliminating 1 0 2 1. So that is equal to 1 into 1 1 0. So cofactor of the first element 1 is 1. Next, cofactor of the second element 0. So this is in R1. I am finding cofactors of first row in R1. Okay. Cofactors of 0, cofactor of 0 B A1 B1. So for 0, here eliminating this row and this column, you get to 2 3 0 1. 2 3 0 1. So for this 0 2, for these 4 elements you get minus. So that is minus 1 to the power I plus j. So other elements will not change the sign. For these 4 elements, it will be minus of this one. So therefore, minus of 2 into 1, 2, minus 3 into 0, 0. That is minus into 2 is minus 2. The cofactor of the 0 is minus 2. Similarly, cofactor of 2. So let this be as C1. So the row and column, eliminating row and column, we get 2 1 3 2. 2 1 3 2. So this determinant is equal to 2 into 2 4, 3 into 1 3, 4 minus 3 is 1. So this is the first row. Similarly, cofactors of R2, second row, cofactors of second row. Now cofactor of second row 2, that is equal to A2. Let us name it as A2. So this one, second row, so this row and column, eliminating row and column, we get this row and this column 0 to 1, 0 to 1, 0 to 1, and for this we get minus 0 to 1, we get minus. So now minus of 0 into 1, 0, 2 into 2, 4, minus into minus plus, this is plus 4. Similarly, cofactor of 1, that is B2. So 1, it is the middle one. So eliminating the row and column, excluding the row and column, the remaining 4 elements 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. So this one, 1 into 1, 1, 3 into 2, 6. That is minus 5. Cofactor of second row third element 0, let it be C2. So for this, the row and column eliminating in which 0 element is there, ఈ 0 ఉన్నటువంటి రో కాలం ఎలిమినేట్ చేస్తే మిగతా 4 నెంబర్స్ 1032, 1032, we get 1032. So for this we get minus sign. So minus of 1 into 2, 2, 0 into 3, 0, that is minus 2. Next, cofactors of third row elements. Similarly, you can find, if you practice, you will be very familiar with these cofactors. Now, cofactor of 3, let it be A3. So eliminating row and column 0 to 1, 0, 0 to 1, 0, 0 into 0, 0, 2 into 1, 2, that is minus 2. Next, cofactor of 2, third row second element B3. So for this we get minus what are the elements? Third row and column, taking remaining 4, 1 to 2, 0, 1 to 2, 0 elements. అది ఉన్నటువంటి రో కాలం ఎలిమినేట్ చేసి రిమైనింగ్ ఎలిమెంట్స్ తీసుకుంటున్నాం. 2 అనేది ఎక్కడుందో వేర్ ఎలిమినేటింగ్. సో 2 ఉన్నటువంటి రో R3 3 2 1 వదిలిపెట్టాలి. 2 ఉన్నటువంటి కాలం 1 0 వదిలిపెడితే మిగిలిన 4 ఎలిమెంట్స్ రిమైనింగ్ 4 1 2 2 0 మీరు ప్రాక్టీస్ చేస్తే it will be clear for you. 1 into 0 0, 2 into 2 4. Which 4 elements we are taking? You observe minus minus plus 4. Next, cofactor of the last element 1. So R3, third element, let us name it as C3. So take the 4 elements, remaining 4 elements after excluding the row and column in which the element lies. ఆ ఎలిమెంట్ ఉన్నటువంటి రో కాలం వదిలిపెట్టి మిగిలిన 4 మూలకాలం తీసుకోవాలి. ఏమున్నాయి? 1 0 2 1, 1 0 2 1, 1 0 2 1, 1 into 1 1, 2 into 0 0, that is 1. Now after finding all the cofactors, now cofactor matrix, cofactor matrix, let us name it as B. Write all the cofactors, that is A1, B1, C1, A2, B2, C2, A3, B3, C3. So this is the cofactor matrix. So this will be A1, B1, C1, 1 minus 2 1. Look at this. First row 1 minus 2 1, 1 minus 2 1. Second row 4 minus 5 minus 2, 4 minus 5 minus 2. Third row minus 2 4 1, minus 2 4 1. So this is the cofactor matrix. Now we want adjoint. Adjoint A is nothing but the transpose of this cofactor matrix. So transposing this, so convert the rows into columns. 1 minus 2 1, this row you write it as column 1 minus 2 1. Second row as second column 4 minus 5 minus 2. Second row becomes second column. Third row third column. థర్డ్ రోను థర్డ్ కాలమ్గా కన్వర్ట్ చేయాలి. ఇట్లా రోస్ను కాలమ్స్గా కన్వర్ట్ చేస్తే అది ట్రాన్స్పోజ్ అవుతుంది. ఇక్కడ ఈ కోఫాక్టర్ మ్యాట్రిక్స్ ట్రాన్స్పోజే అడ్జాయింట్ ఏ అవుతుంది, అనుబంధ మాత్రిక. సో దిస్ ఈజ్ హౌ వి ఫైండ్ అడ్జాయింట్ ఆఫ్ 3x3 మ్యాట్రిక్స్. ఫస్ట్ ఫైండ్ ద కోఫాక్టర్స్, దెన్ transpose the cofactor matrix, you will get adjoint matrix. So this is adjoint matrix. Now let us find the determinant of A, det A. So that is A1 A1, B1 B1, C1 C1. So this is the definition of determinant. Sum of the products of element with their cofactors. So this is the definition of determinant. Now first row, first element is 1 and its cofactor, one cofactor is 1. The second element is 0 and its cofactor is -2. Third element is 2 and its cofactor is 1. Look at this. 1, 0, 2 are the first row elements and their cofactors 1, -2, 1. These are the first row elements and first row cofactors. So that is det A 1, 0 into anything 0 plus 2. So 1 plus 2 is 3. So determinant is det A is 3. Remember, determinant is a scalar. ఇది ఒక సంఖ్య. Now we want inverse. So now by definition A inverse is equal to adjoint A by det A. So therefore here now let us write adjoint 1, 4 minus 2, 1, 4 minus 2, minus 2 minus 5, 4, minus 2 minus 5, 4, 1 minus 2, 1. So this is adjoint. So determinant is 3. We write it as 1 by 3. So this is the inverse of a 3 by 3 matrix. So to find inverse, we need adjoint and det. First find adjoint and determinant, then you will get inverse of any 3 by 3 matrix. This is very, very important concept in this chapter, how to find adjoint and inverse of 2 by 2 and 3 by 2. We did both. So how to find adjoint of 2 by 2 and inverse of 2 by 2 is first example, first problem. It is simple for finding inverse of 2 by 2 is very simple, and finding inverse of 3 by 3 you need to follow. If you practice 1, 2, 3 problems, it will be very easy, familiar for you. First, finding cofactors. You look at this very particularly. You have to selecting you should be a little bit careful while selecting the 4 elements. How to select the 4 elements? First, neglecting the row and column in which the element lies. ఒక ఎలిమెంట్ కోఫాక్టర్ కనుక్కోవాలంటే ఆ ఎలిమెంట్ ఉన్నటువంటి రో కాలం వదిలిపెట్టి మిగతా 4 మూలకాలను తీసుకోవాలి. ఫస్ట్ సెలెక్టింగ్ దిస్ 4 ఎలిమెంట్స్ is very important. So neglecting the row and column. So for 1, neglect the row in which 1 is there, neglect the column in which the element 1 lies. Then take the 4 elements. Like that for each element, ప్రతి ఎలిమెంట్కు ఇదే పద్ధతిలో అది ఉన్నటువంటి రో అండ్ ఆ ఎలిమెంట్ ఉన్నటువంటి కాలం వదిలిపెట్టి మిగతా 4 మూలకాలను తీసుకోవాలి. సో ఇట్లా హౌ టు సెలెక్ట్ 4 ఎలిమెంట్స్ అనేది మీరు జాగ్రత్తగా గమనించాలి. లిటిల్ యూ షుడ్ బి వెరీ కాషియస్, లిటిల్ బిట్ కేర్ఫుల్ while selecting the 4 elements. For all the elements, just you practice how to select the 4 elements out of this 9. And then you remember this 4 second element in first row, first element and third element in second row, and second element in third row For these 4 elements, cofactors will get minus sign. This you should remember. Then the rest is very simple. ఇది మీరు జాగ్రత్తగా 4 ఎలిమెంట్స్ రాసుకున్నట్టయితే మిగతాది సింప్లిఫికేషన్ వెరీ ఈజీ and you will get the cofactors, and after getting the cofactors and transposing the cofactor matrix you will get adjoint. And determinant, you know, element and its cofactor, element its cofactor, already we calculated the cofactors, that's why I am taking 1 minus 2 1. Otherwise if you want only determinant you have to take element into this 4, element into this 4, element into this 4. Already we did in the last class how to find determinant of 3 by 3 matrix. So after finding adjoint and determinant, A inverse is equal to inverse adjoint by determinant. So you practice some more problems. You will be familiar with this. So I want to conclude this lesson here. Just go through and prepare your notes and practice some more problems from the textbook. Thank you for watching.